Okay, so in this video we're going to deal with voltage and potential difference and electromotive force. Now all of these terms, PD, potential difference, electromotive force and voltage, share one common feature, is that they're all measured in volts, okay? Now we need to be able to define the volt first of all. So defining the volt is very simple. So a volt is just, using an equation that you're given, is W over Q. Now that equation is voltage equals the amount of energy per unit charge, because Q is charge. So energy per unit charge means that a volt essentially is what we like to term a joule per coulomb. Okay, so joule per coulomb is what a voltage is, or what 1 volt would be. So 1 volt is 1 joule per coulomb. So that's an amount of energy that's transferred by the charge that is moving round a circuit. So hence, the more voltage you have, the more energy that the charge is carrying around with it when it moves around the circuit. Okay, so in order for you to understand the difference between EMF and potential difference, we need a circuit to help us out, really. So I'm going to draw a nice circuit here. I'm going to put in a resistor and then a voltmeter as well. Okay, so we've got a circuit there, very simple circuit with a cell, a resistor and a voltmeter attached in parallel. And so what we're going to do with this is just demonstrate what's happening here. So if I have a cell that's 3 volts, then practically what we'd expect to measure on our voltmeter would be 3 volts as well. Now, because you're imagining that as the electrons travel around the circuit in this direction, they have got that amount of energy that's suggested per unit per coulomb of charge that's carrying that energy, and as it passes through this resistor, it's going to transfer that energy into heat energy, okay, because it's got to do work moving through that resistor. So it's got to actually do work, and by work I literally mean work done by the electrons on the resistor as it moves through there. So what we have here is a situation where it's transferring the energy per unit charge it has into heat. And so what we're seeing about this 3 volts that we're reading out here is that initially we had 3 volts of energy per charge that was carrying it. And as it comes down and round here, it passes through that point right there. And the voltmeter recognizes, right, okay, each coulomb has 3 volts. As it passes through, it expends all of that energy until it has 0 amount of energy at this point right here per coulomb. And so what effectively this voltmeter is reading out is what we call a potential difference, because it's measuring the difference in potential, i.e. the energy, between this point here and this point here. And as a result, we can say, okay, well, it came in with 3 volts and it's leaving with 0 volts, so the potential difference is 3 volts. So that's what potential difference means. So slightly differently now, we have an EMF. And an EMF is not so much what you're getting out or what you're using up, it's what you're putting into a circuit. So in this case, the EMF, the source of electromotive force, is right here. Because what we have is a situation where the electrons are given an electromotive force by the fact that this battery, or this cell even, has a negative charge there and a positive charge there. And so as a result, the electrons are forced, I choose my words very carefully, forced around the circuit in that way, as we've just shown. And that's all due to the electromotive force produced by the cell there. So it has an electromotive force of 3 volts. because that's how much energy we're giving it as a result of the positive and negative charges on either side of that, either side of the cell. Right, so if we were going to define in words what EMF was, so EMF is an amount of chemical energy that's transformed into electrical energy per unit charge. Because inside the battery, or inside a cell, we have chemical energy. Because chemical energy is essentially how batteries store their energy. It transforms that into electrical energy when it is connected to a circuit and allows an electromotive force to be set up, causing the electrons to move around the circuit. So PD is slightly different. So PD is an amount of energy, electrical energy, that's transferred into other types per charge or per coulomb. So EMF is the amount of chemical energy transferred to electrical energy in the circuit, and a potential difference is an amount of electrical energy that's transferred to other types within the circuit. So for example, you might have a light bulb. So a light bulb uses the electrical energy and it's transformed into the light energy and heat energy you'd expect when you use a light bulb.